Hi, my name is Kevin, and welcome to this, what's literally the first tutorial for running a game on the Spectrum Next. Now, in 2020, I got the ZX Spectrum Next, and after 3 years, it kind of arrived. Woo! Okay, and the first thing I thought of doing as soon as I got that is, hey Kev, you can finally get back and do all those cool things, running your own games and playing around in BASIC for a bit of fun. And while you're at it, why not make some tutorials? I thought, well, yeah, it's a good idea. Could be a lot of fun sharing some of that stuff around and getting it kind of like a little community thing going. But 2020 came and it went, and it's right at the end. And finally, I've written a whole pile of games, but not a single tutorial for any of them. So this is a first right at the very end of 2020. So have fun. I hope you enjoy this, and hopefully it was worth the wait. So what I've got is I'm going to start with a nice simple game. It's a Lunar Rescue game. You can see I've got like an illustration here. I always do this, and I'm sure I've seen everyone else do it as well. You always have to start somewhere. So you draw your ideas up and you make some notes on it. I've got like hundreds and hundreds of notebooks full of game ideas and scribbles. A lot of mine I'll start with a drawing, and then I'll actually end up literally almost coding it on paper before I even get to the computer. But for sake of this, I'm going to code it on the computer, and we're going to kind of work through just building it. So anyway, you can notice I also did like an illustration. I thought, well, why not? I've got illustrations for literally everything that I've made up. I get carried away drawing like little illustrations, and the chance I might want to make a 80s style magazine mock-up with a program listing in it, because maybe I'll force everyone to experience the 80s all over again and manually type these in instead of distributing them online on the net. I would never do that to anyone because I know that would be painful. Okay. Anyway, before my insanity takes over for this introduction, let's have a look at the game itself. So the game is literally all about learning how to fly a landing pod and how to bring it down to the surface of a planet at a right speed, at a nice, safe speed, rescue an astronaut, and then fly them up to a kind of a rescue pod at the top. So the challenge for the player, really, in this respect, is going to be just getting used to learning to fly, becoming the like a qualified pilot of a landing pod, because it's going to have thrust, it's going to have gravitational pull. If you don't push the thrust button, it's going to drop with gravity and it's going to get faster. When you go sideways, it's going to slowly increase the speed as you kind of thrust it left and right. And then, of course, you're going to have to thrust the other way to slow it down. So very much like your typical spaceship, I guess. Okay, so let's get started. You've seen my idea. You've seen my wacky illustration. Let's go and actually have a look at the first thing I did, and that was draw a bunch of sprites. Now these may not be the finished sprites, as in like the final sprites, but they're enough just to get me started. In fact, they're not too bad. I want to get something really simple and retro-y looking, 80s classic 8-bit stuff. So what I've done is I've used this website, zx.remisharp.com. Now Remy makes some really cool tools for the ZX Spectrum Next, and he's been a bit of a key player in the community in terms of getting some tools together. I like these tools because, one, they're really good. I do have other tools like UDG'd, and there's the ones that come with the Spectrum Next. But what's nice about this is it's online, so I can access it wherever. I don't need to take any installers or install some software, which makes it kind of a lot of fun. Now, I originally started using this because I was using UDG'd for all my graphics, because it had an importer that you could import a PNG, and you could then go and you could cut out graphics. And I've got like a whole ton of graphic files from the 80s lying around with lots of sprites and things that my brother and I designed, and I wanted a way of kind of stripping those out so I could use them in the next projects. So that's where I originally started, and it was actually really handy. But I'm just getting used to just doing all my sprites and everything else on here. So what I've got here is I've got two sprites at the beginning. One is the ship that you're flying, one is a ship with a little flame on the bottom when you're pressing the thrust button. You've got like a little 8-bit looking astronaut guy. Person, I should say. I got 3 terrain blocks. Okay, so blocks of terrain for doing kind of like a very simplistic moon surface, I guess. I did do a 5-frame animation because I thought, well, you're going to crash probably a lot because, you know, it's not that easy to fly a landing craft, so better have something spectacular to show what happens if you don't know how to do it properly. And then I wanted something at the top, which is going to be like the, I guess, mothership or rescue pod that you have to, once you've rescued an astronaut, you have to fly back up and dock with it to drop the astronaut off. Okay, so I've done this. It's kind of looks like a pair of claws. But I actually have drawn 2 other parts that I thought what I might do is, rather than having one little square, be cool to have like 2 side details that make it look more like a bigger ship. But more about that later. Okay, now I needed to also work out a bit of a plan where things are going to lay out on the screen. And what's really nice with the Spectrum Next is it supports things called tile maps. Okay, and tile maps can use these 16 by 16 pixel blocks. And we go across on Remy's website. He has a tile map tool. Lets you draw these and you can save them off and bring them in. Now, tile map is kind of like, think of it like kind of drawing a screen based, like the layout of a background for a screen. As a big map that uses a whole bunch of different tiles to kind of draw it up. So you could draw up like the moon surface like this and put some stars in the background and everything else and export that out. Now, what happens when you use a tile map is when you display a tile map, it basically is like printing all this stuff onto the screen. Okay, so it's good for backdrops and environments and things like Pac-Man mazes and stuff. But to keep this simple, and because I want to make it, it doesn't take a lot of work to do it with sprites. I just wanted a bit of a plan where I was going to play stuff. So I use this more as a testing ground for drawing and graphics to see how well they'll look. Like, for instance, put these other 2 on and see what they look like. Sweet. But I wanted to draw the terrain in here and get an idea where to put it. And when I said work with sprites, because it's easier, I'm going to make not a background tile map that has this stuff in here. I'm going to actually use sprite objects and then place them on the screen with the right graphic, so that one thing you can do is you can kind of automate detection of collision between sprites. Okay, with background images with the tile map, you have to kind of calculate where the things would be if you were to crash into them and everything else. And it's much easier just to do an inter-sprite collision thing. Okay, but more about that when we get to the programming part. I'm starting to waffle on about technical sides of things. Okay, just went through and I've made kind of like a bunch of notes. Ooh, put that across there. Not that you can read any of that. With all of the different patterns down here and the X location or the Y locations up and down, because they're going to go from 0 to 15. And I just need to know how high they were and what graphic they were going to represent. Okay, and I've got all that written down. I wrote down where all the astronauts would stand. Okay, and that kind of looks alright, so I'm pretty happy with that. In fact, I'm going to just work like that for now. I might put those side ones on later on. Okay, and I've used it as like a planning tool. So sprites are done, tile map planning, lots of note taking. Okay, I've downloaded this and I've put it across, and what we'll do now is we'll go across to the Spectrum Next and we'll start looking at how we start putting that together. So let's have a look. So for this I'm going to be using CSpect. So CSpect is the emulator that a lot of people are using, that or ZSRUX. And basically it lets us do all our development on our PC rather than on the physical machine. Okay, so it saves a bit of wear and tear, and it's a lot faster. In a way, it's a lot faster and a lot kind of safer because it's on this big box rather than that little thing that if it craps itself, you lose it all. You lose it all here too, but hey, feels better, honest. And also, it lets me screen grab it. That's probably the most important part. Okay, so we've got our Spectrum Next. Let's tap the space bar. Okay. Okay, I'm going to go to a browser. Okay, and I've made a folder on my virtual SD card called KP, and in there I have all my little mini game projects. So lander, And I've already copied across the sprite graphic file that I drew online. So this one here. Okay, to do that, I actually used a program called HDFM GUI. Okay, it's quite handy. It lets you basically write copy files between your hard drive and this virtual SD card image that the emulator is using as though it was the SD card in the machine. Okay, so that done. Now all these tools you can find links to in descriptions, where to find them and everything else. A lot of the Spectrum Next, I guess, websites, forums, probably also I'm guessing the Discord channel, and also on Spectrum Next Facebook page and everything else. Okay, so let's I'm going to open that just so we can just make sure it's the right one. Okay, they look like all the sprites I wanted. I'm pretty happy with that. Okay, so let's get out of that. Okay, let's shift and space to break, go back here. Okay, I'll leave it at 3.5 megahertz, why not, and go NextBasic. Okay, so now we're in NextBasic. So I went browsing to that graphic file, which should have set the Spectrum to point to that folder. So when I work with my basic program here, it should be inside that folder area. Now, if you're not sure where you are, if you go .ls, what it'll do is it'll actually show you, basically list the files in the current location that you are on the SD card, like a .ls is list. Looks good. So we're going to start, and we're going to start by, I'm just move my microphone out of the way. I'm going to start by, well, let's just start writing some code. So I'm going to start line 1. Rescue tutorial, and by Kev. There we go. Okay, just to be pedantic, I'll put a space there. Okay, so I always put, I'm going to extrapolate out the stuff, so I'm going to always put like comments in here as I go, and I'm also going to use long, I guess, meaningful variable names as I go as well, just to kind of make everything a bit clearer about what does what and what is called what. Spectrum Next does have some other features in it that let you optimize your program to run a little bit faster, but this is such a simple game that it doesn't really matter too much. I will look at some of the optimization stuff at a later time, but maybe after we finish this. But okay, so I'm going to start off. I'm going to go, and I'm going to start the first line number 5, I should say. Lander, and I'm trying to remember what the name of that file was. Lander Rescue GFX.spr. Lunar Rescue. Lunar Rescue GFX.spr. Okay, so I'm going to load the sprites in, and I'm going to load them into a memory bank. So I usually use bank 15 because it's a nice empty one, and why not? Okay, so we've got that. Let's go 10, and we're going to go, and we're just going to make sure we tell Spectrum Next where to find these graphics. So you use sprite bank and specify what bank is going to have those graphics in it. Okay, I'm going to steps of 5, and I'm going to change line numbers as I go and just maybe talk through what I'm doing. So okay, so I'm going to go sprite clear first. Sprite clear will just kind of like not clear the graphics. The graphics aren't technically sprites. They'll call patterns. Sprites are these little entities, I guess, in the hardware that basically get displayed on the screen, and they can have different graphics from this bank. But I won't waffle on about that. So sprite clear, we're just going to blank them all out so it's fresh. And I'm going to go sprite print 1, which will tell me, well, tell Spectrum Next, okay, I want you to turn on printing of sprites. So when the sprites get drawn on the screen, they'll appear. And I'm going to say sprite border 0, because the sprites have a different coordinate system. They go all the way out from the top corner of the the top corner of the border to the other side, and the spectrum screen is this little block inside the border. So what we can do is we can just tell them not to appear on top of the screen when they're in that border area. Okay, sweet, done. So we're going to set the screen. So I'm going to say border. I'm going to give it border. Oops, and that's a bug in C-Spect. Easy enough to stop if you just go Shift 1, the exclamation, and that tends to stop that repeating thing. So border 1 is going to be blue. Paper, which is the background 0, which is black for the background of the screen. Ink 7, which is the color of the, I guess, the text. And CLS. Okay, now these things, important thing to realize here is if you've been looking in the manual, or you've been talking online and people start talking about layer 1, layer 2, layer 3, we're using what's termed layer 0. Layer 0 is the generic ZX Spectrum screen mode, or ULA mode, that has the 8 colors plus bright plus flash and everything else. So the color IDs in here are 0 to 7, 0 to 8. Damn it, I can never remember. Let me have a look at the real thing. Okay, it's 0 to 7, and then you have a bright and you also have a flash. Okay, for the different colors. Okay, in layer 1, layer 2, I guess layer 3. Don't know yet. That's still coming. They have 0 to 255, so they have like a broader range of colors. So I don't need to switch to one of those high color modes. I don't need it because we're just doing sprites on top of just whatever. So I'm going to go here, 25, and let's define some variables for our little lander. So we're going to say let x is let's say about 100 pixels across, and let y equals, we'll say about 32 pixels down. Okay. Now, interesting with the Spectrum Next is you don't have to use the command let on this version. This is version 2.06N, I think, or sorry, of the NextBasic language. You can just go x equals 100. So you don't need the let there, but I like to use let because, well, it's just nicer, to be honest. It looks like basic. Plus, if you go, it turns letx into a variable name, so you do a typo, you're like, oh, whoops. Okay, so anyway, before I start going off on a weird tangent there, x and y, those are physical locations. I'm going to go let vert equals 0 and let hors equals 0. So vert and hors, or horizontal, are going to be the values that I'm going to use for the velocity or the speed. So they're going to be like little values you add to the position that are going to increase and decrease based on thrust and gravity. So they're like little additive values or subtractive values. So think of like the speed controls, I guess. Okay, so I'm also going to do one called let border equals 32. Now, BRDR or border or whatever, I like to have that in here because I like to work in my game within that area, the normal spectrum screen area. So rather than using all the values inside my sprites going for x equals 32, meaning 0 to 320 minus whatever, I like to kind of use the 0 to 256 by 0 to 192 and just add a value to it, so to push it out of the border area. Okay, so it just uses, it's easier to have the same numbers to work out the relative numbers, and then the 32 is just added on when it displays it to the screen to push it in the right place. Okay, so let's finish there. Okay, sometimes when I'm doing remarks, and I'm going to put a lot of remarks in as I go, Get ready to rumble. I like to use like singular steps, okay, for my little blocks. So what I'm going to do now is I'm going to put some space in here because I'm going to set up the basic the ship motion, the control system. So just the main core of the game, really, the piloting part. And I'm going to put like a block at the front because I want some space in here. So when I come in here and I go, well, actually I want to just start adding some features, I don't have to go through and go, well, I have 45. Oh, I need to have some more lines in there, so I don't have to start renumbering the entire program and shifting things around. I'm going to give a bit of a gap. I'm going to start at 100 for the game. Okay, so it gives me 40 to 99 as a bit of extra spacing to put some more code in. So, okay, so here's where the game loop will be. Now, all games have a kind of a loop or repeat. That's like a spacer there. So generally what happens, of course, with a game is you have a bunch of steps that happen. You read your keys, you print your sprites to screen, you check for collision detection, you work out if you've won the game yet, and if not, go back and you repeat it all again, and you do it over and over and over. So we're going to start off, first of all, by just seeing if the player has pressed a key for left, right, up, thrust, up. So for that, I'm going to go if, and I'm going to use the basic command InKey $ to read a key on the keyboard. Now the problem with InKey is it can only read one key at a time. So if you press 3 or 4 keys down at the same time, it'll only read one. But we'll fix that later on, because what we'll want to do is we will want at some stage to be able to move left, right, and tap the thrust key at the same time. But for sake of testing and making sure that works, I'm going to do it this way, and then we'll go back and we'll actually change things around later on just to give us that capability. So O, use OP in the space bar for playing. So O is that way. Okay, now coordinates start 0, 0 on the far left. So to make it go left, you have to subtract a value. So we're going to say that will be the HORZ, HORZ. That's our little speed for horizontal that way. So first of all, we need to set some limits to that. We don't want to, as we're doing that, it's going to increase the speed. We don't want to get ridiculously fast and have it fly out at some incredibly high speed that we can't stop. So we're going to say if the key was pressed and, okay, it's going to be a negative number. So as long as the horizontal speed is greater than, we'll say maybe the fastest is -8 pixels that way. So if it's pressed and, that has to be like not outside a bound, I guess, or the maximum speed. Then we're going to let HORZ, whatever the value is, -1. Okay. So let's go to the next one. Let's in fact, let's just copy that line. So let's go to a line and just change the number, and we'll just basically make a copy of it. And we do the same here, but I'm going to P for the right. So that's adding plus. So in horizontal movement is less than 8, right? +1. Sweet. Okay. Now let's go if InKey $ equals, oops, spacebar, and that'll be the vertical speed. Okay, it's going up when you're pressing the thrust key, so that's a minus because it's going up to 0. So it's greater than, and we use the same values, -8. Equals vert -1. And 120. Okay, 120. Now, we didn't want to copy that because if you look at 120, if we don't if we don't press the space bar, the gravity should start pulling back, right? So what the game is you'll thrust it up, and then as soon as you let go of the rocket engine, it'll start falling back down with gravity. So really we just want to go if vert is less than 8, because we're going to increase to push it down, then let vert equals vert plus 1. Okay, so that's not going to work just like that, because what's going to do is if you press space, it's going to subtract it, and then the next line it's just going to increase it. So what we need to do is say if we press thrust, let's decrease the speed, and then let's jump over that line. Okay, so we're going to go to, let's go 130, why not? Okay, so look at the thrust. If you press thrust and it's in that, it'll do that, and then it'll skip down to the next step. Okay, if you didn't press thrust, then it's just going to have a look and it's going to start making it fall downwards. Okay, so let's have a 130, and let's just do some comments here. I'm going to move the ship and display. Okay, always put like a single line there. Okay, so we're going to let x equals x plus HORZ, right? So we're going to add our horizontal movement to the x in case it's plus or minus, and then we're going to let y equals y plus vert. Okay, so then adding the direction up and down. So that should update the position. 140. Okay, and I'm going to draw the sprite to the screen. Now the sprite I'm going to use is 0. That's the very first sprite. And you have up to 128 sprites. Like I said, they're just entities with their own little XY coordinates and everything else, and their own kind of graphic that you assign to it. So I'm going to make sprite 0, comma, and it's usually X. Okay, now we need to do that border just to push it into the right part of the screen. So I'm going to go X plus BRDR. And we go Y plus BRDR. Now it's just adding it temporarily. We're not adding it to X. We're saying sprite and the value uses X plus the border. Right. So if you're kind of confused because maybe you're not doing a lot of programming before and you're thinking, well, won't that increase it? No. To add that BRDR, and you have to go X equals the value in X already plus that to add it onto it. Okay, so just thought I'd throw that in there. 0 pattern, which is the first graphic, and then we need a display flag after that. Now display flag, you've got a lot of options. You can say don't draw it, and you can also rotate it and draw it, and flip it and draw it as well. Now just to draw it, just 1. And that will draw it on the screen for me. Okay, and then I'm going to go down, and I need a bit of gap in there because I'm going to have a whole bunch of other stuff, maybe for checking if it's crashed and rescued and stuff. So I'll get a line 200, and we're going to go to line, game loop is back up to 100. Okay, so it gives me like a line 140 down to 199 to add more code in there, and that should do it. So let's run and see what happens. Woo. Okay, so O and P. Okay, so we're going to go as vert, HORZ. Okay, so it didn't work straight away. Let's have a look and see if we can figure out what's going on here. So reading the keys, horizontal, O, P, +1, space, and the vertical is greater than -8, then vertical is vertical -1, and we get to 130, vertical is smaller than 8, then let vert equals vert, no, +1, that's right. Let's run that and see what happens. Left and right works fine. Okay, so as you can see, press O, it goes. Press O again, it's a bit faster. Press P. Press O again, just to kind of... So this nice kind of like bouncy velocity thing going on. Now, for some reason, the spacebar is not working. So if key equals spacebar, okay, I'll tell you why. It's nothing to do with that. It's this thing here. This is why I'm doing that. There we go. Now the vertical's working. Okay, and then hold down thrust. Oh, okay, and it can go at the bottom of the screen. Okay, so it's working. Great. Now it's a bit fast. So what I might do is I might just go in here and I'll make it more granular. So the increase, instead of being plus or minus 1, let's make it that half as much. So 0 0.5, 0 0.5, 0 0.5, 0 0.5, and let's go run. It's a bit nicer. Sweet, and that's the main, that's the main part of our, you could say the game mechanics. It's all about the navigation. And you can see how the ship appears to disappear inside the blue, the border. Let's go at sprite border 0. Now it goes down there because there's two blue lines at the bottom. Are actually not border lines. They're like the bottom two text lines on the spectrum. So they just, wow. Okay, so I'm happy with that. Let's stop that there. So let's save this. I always put like line 9999. And go save Lunar R. Why not? Lunar R.bas. Now I like to put mine at the end. Just go to 99999. And then I like to just change it so next time it saves with another name on. If you're wanting to make sure it saves every time you start, you can always put the save at the top, so it saves the file before it runs it. Personally, I'll do it and then I'll just go 9999 before I run it. But it's up to you. I mean, so list looking pretty good. Now you notice the sprite's still on screen, so let's sprite clear as a quick way of just getting rid of those. Okay, so we've got a good start, and let's put like a gap on that. Okay, so hopefully that makes sense so far. Saved it, and what I'm going to do is I'm going to finish it here before I end up with one long, it's already up to 33 minutes, one long over the top video, and I'm going to split this into a bunch of smaller videos. So what we'll do after this is we'll come back and we'll start looking at maybe adding some check so it kind of doesn't go out of the screen, come up that weird B variable out of range, and then also look at how we can put some terrain in there. So I'll see you in the next video.